Alright, welcome back. Okay, before we go and talk about the steam table, I just want to bring attention to just now what we mentioned about the two different diagrams, right? PV curve, PV diagram, and the temperature volume diagram. So over here, I have explained previously that if you are going under the constant pressure, the boiling kettle, you go from the left side all the way to the right side, you will cut across the liquid to the wet steam to the superheated state. Okay, how this is indicated on the TV curve is actually much more simple. So for example, just now we were talking about it starting from 25 degrees Celsius. So at temperature starting from 25 degrees Celsius. Okay, and imagine this is the constant pressure line of atmospheric pressure, 1.01325. Okay, you are actually starting from here. Okay, 25. And then it starts to, you see this line, it starts to boil it starts to increase in temperature at constant pressure, right? So at constant pressure, meaning that it is going along the same line. So you will see this going up. The point is moving up. So the temperature slowly start to increase as it hit 50, and then slowly as it hit 100. Okay, then you reach this point. So this point is the equivalent of this point over here. These 2 points are the same. Okay, and after that, right, you will see that the evaporation, boiling starts to happen, and they go to the same along the same path. Okay, along a similar pattern until it reaches here, and then the further heating will go into the superheated region to hit 150. You can also see it from here as it goes along up to the constant temperature line as it hits 150. Okay, so this line, this process is the same as this process from here over to here. Okay, so just like to bring your attention to this. Alright, so the next thing that we are going to talk about is the steam tables. This is a very important aspect of this chapter. Okay, some may have gotten the Thermofluids 1 book from the bookshop, and you will have these steam tables provided. They are, and the bookshop also sells this book by Rogers and Mayhew. This is the whole thermodynamic and transport properties of fluid itself. This is also considered what we call the steam table. So these are equivalent. Okay, for this, the tables have been arranged to be similar to this book. So when I refer to this book, it is the same as referring to this. Okay, with the exception that let's see, the paging. Okay, so maybe if we say the very first page of the Rogers and Mayhew book is actually page 2. Actually, it will tally with the appendix 2, A2. Okay, A2 of this stack of steam tables. So I'm just gonna go through with this book. Okay, so right off the bat, okay, we can start with page 2 first. You will see that the title is Saturated Water and Steam. It means that you are talking about areas that is here, these values. Okay, what the steam table provides are values, but not all values in the entire diagram. Okay, it will give you key values so that you can use the key values to do something like an interpolation for the exact values for your problems. Okay, so like I said, this page 2 is about these 2 lines. Okay, it is not about the superheated region. Okay, why do I say that? Because if you look at the first column, temperature. Okay, so the first column is temperature going by degrees Celsius. It goes by according to from 0.01 all the way to 100 degrees Celsius. Okay, and the second column is the pressure. Okay, this pressure is the pressure which this temperature is the boiling point. Okay, so if I say your most familiar one is atmospheric pressure 100 degrees, right? So it is exactly the last row. 101.1325 bars. This is bar. The unit is in bars. And the corresponding boiling point is 100 degrees Celsius. Okay? The third column, okay, is VG. Okay? VG is specific volume. You see the units meter cube per kilogram. Specific volume along the G line. Okay? So, in fact, VG is this value over here. If atmospheric pressure, okay, this is the G line, so VG is this value here. This is VG. Okay, and this value, if I look at atmospheric pressure, will be 1.6673 meter cube per kilogram. So this value is 1.673 meter cube per kilogram. Okay, so this is what VG means. Alright, so the next three columns are about enthalpy. Okay, note that the units are in kilojoules per kilogram. So these are specific enthalpies. Okay, going by kilojoules. So it means that the HF is the enthalpy at this point. Okay, along this line. If I say atmospheric pressure, the HF, the enthalpy at this point will be this value, 419.1. Okay, and Hg is basically the enthalpy along the G line, which is here. Okay, so this value, you look at Hg, is 2675.8. Okay, one thing to note though is that this book and this booklet, their values will differ by a little bit, but it's roughly similar. So when you do your questions and you find that the answers given differ by a little bit, do not worry too much, okay? Because they might be calculated from the other steam tables that you are using. Okay, and so this is about HF and Hg, right? So the middle column HFG is simply the Hg minus HF. It is that difference, okay, between the G and the F. Hg minus HF. You just try to subtract this, you'll get this. Okay, this HFG is effectively the energy required for you to convert the 1 kilogram of saturated water into totally dry saturated steam. So this is called the latent heat of vaporization. Okay. Okay, the last three columns are about entropy. S is entropy, which will not be covered for thermofluids 1. Okay, but you will be covered for thermofluids 2. Okay, so this is page 2. The next couple of pages is actually very similar, except with one key difference is that instead of the first column being temperature, right, from 0 to 100, you are now talking about looking at pressure, increasing pressure. Okay, and this page 3 starts from a very, very low pressure all the way to 1 bar. Okay, all the way to 1 bar. And you will see that at 1 bar, which is very close to atmospheric pressure, the boiling point is just slightly below 100 degrees Celsius. Okay, and you also get VG, HFG, HF, and HG. And there's one column here is UF and UG, which is the internal energy, okay, specific internal energy, also along the F line and the G line. Okay, so if you are asked to find internal energy, then you use these two columns. If you're asked to find enthalpy, then you use this column. Is that it? And the units are also in kilojoules per kilogram. Okay, so this is all the way covered. You will see the next page, it starts from 1 bar all the way to 40 bar and carry on from 40 bar all the way to the limit. This is actually the top of the hill, 221.2 bars, which is here. So this top of the hill is here, 221.2 is this point. Okay, and that's it. That's practically describing the entire hill, the values along the F line and the G line. Okay, that's what these first few pages are about. And the next page, right, page 6, is different. Straight away you see that the title is called superheated steam. Okay, superheated steam means that now it is giving values right in this region, the right side of the hill. Okay, so how do you see it? It goes by as indicated on the top row here. Okay, the first value is the pressure in bars. Okay, so let me pick out one. Okay, 1 bar. Okay, so the first value is in bar, and the number in bracket 99.6 is the boiling point. Okay, and this particular column is just talking about the values at the G line. Your specific volume, your internal energy, your specific enthalpy, and your specific entropy. Okay, Vg, Ug, Hg, Sg. Okay, along this line, the G line. But these can also be found in your previous page because you have your Ug, you have Vg, you have your Hg, you have your Sg. So these values are actually repeated over here. Okay, over here on page 6. So if you're looking at superheated regions, you're actually not so concerned about values over here. Okay, so at the top row again, let's see, these next few columns are all according to different temperature values. Okay, 50 degree, 100, 150, 200, 250, 300, 400, and 500. This means that, do I have a pencil? Okay, it's alright. So, how these are organized is this. So let's go back to 1 bar again. Okay, 1 bar, you see the letters V, U, H, and S. Okay, it means that each row, this top row, is the specific volume. All of these numbers are specific volume. The second row is specific internal energy. The third row is specific enthalpy, and lastly specific entropy. So if I want to talk about 1 bar, 250 degrees Celsius, straight away you go from 250 down and you look at 1 bar. Okay, and these 4 numbers will be your values. So at 1 bar, 250 degrees Celsius, my specific volume will be 2.406. My internal energy will be 2734. My enthalpy will be 2975. And my entropy will be 8.033. Okay, so this is how you see it. It's one cluster, representing each temperature and each pressure. Okay, so they are given in intervals of 50 degrees lah. Okay, you can see for the next page as well. So it goes on. The page 6 is until 4 bar, and page 7 will carry on for 5 bars. Okay, until 70 bars. And page 8 will carry on to higher values all the way until the maximum limit to 1.2 bars. Alright? And the reason why sometimes you see these blanks, right? Why do you see these blanks? Actually, it's very, very straightforward. Let's say you're talking about 1.5 bar. Why is the 100 degrees, why does the column 100 degrees has no numbers? Simply because it has not reached the superheated region yet. At 100 degrees, at 1.5 bar, your water has not even boiled. So there are no values. Okay, these values are all superheated values.